Hey all, today we're going to talk about two special kinds of triangles, isosceles and equilateral triangles. So I just want to recap, sort of like re-go over a few triangles we spoke about a little bit earlier in this unit. The acute, obtuse, and right triangle. I just want to point out that an acute triangle has all its angles less than 90. So you can see all these angles are less than 90 degrees. An obtuse triangle has one angle that's larger than 90, so my 124 degree angle. And of course, a right triangle has one angle that is 90 degrees. The two triangles we want to focus on today, though, are isosceles and equilateral. So if you look at my isosceles triangle, I have two sides that are the same length, both 2.4. And it has two angles that are congruent or the same measure, 24 degrees. So an isosceles triangle always has two angles congruent, two and only two, and the sides opposite of those angles are also congruent. So my sides that are congruent, marked with these red slashes, are across from the two angles that are congruent to each other. So in this isosceles triangle, we have this side that's the one that's sort of like the oddball out, the one that's not equal to either of the other ones. We call that the base. So another way to remember which angles are congruent, the angles are the base angles. They're the ones next to the base. They're congruent. And the two sides that are not the base are congruent to each other. In my equilateral triangle, I have all the sides that are congruent. They're all the same size, so you can see they're all 14.9. I've also marked them all with these slashes showing that they're congruent. And then also all the angles are 60 degrees. Which we can also say all the angles are congruent. So in an equilateral triangle, the word equal sort of stands out there. All the sides are the same and all the angles are the same. So of course what we like to do when we have some geometry facts is we like to connect that to some sort of algebra. So I'm going to do a few examples for you. Here I have a triangle and I notice that I have two sides marked to show that two sides are congruent. So this is isosceles. These two sides are congruent. That makes this other side the base. And that makes angle 2 and this angle that's 73 degrees my base angle. So that means they should be congruent to each other. So I can write an equation that sets those two equal to each other. Negative 5 plus 13x equals 73. And then I can solve. And I'll find the value of x to be 3. In my next triangle, I have these two sides congruent, making this guy over here my base. 45 is one of my base angles. Angle 2 isn't a base angle, so angle 2 is not the same as 45. This other angle over here, this other base angle, is also 45 degrees. So all three of these angles, this one that's 45, this other base angle that's 45, and angle 2, which is 8x plus 6, they're all three interior angles in a triangle, so they should all add up to 180. And then I can do some algebra and solve to find out that x is 12. So it's very important to locate the base of the isosceles triangle, and the two angles that touch the base are the ones that are equal to each other. In my last picture, I have three sides that are the same. And so that makes this an equilateral triangle, meaning that all of these angles in the triangle should be equal to 60. So since angle 2 is x plus 4, and angle 2 is supposed to be 60 degrees, we set those two things equal to each other. And we can solve that equation to get that x is 6, or I'm sorry, x is 7. So we showed in this these last three, what happens when you know the sides are congruent and you want to find x using angle measures. We could do the same if we know angles are congruent. So I know in this triangle that these two angles are congruent to each other. That makes this the base of my isosceles triangle, meaning that these two other sides are the sides that should be congruent to each other. So these two should have the same length. So x plus 17 should be equal to 9. And therefore x is equal to negative 8. In this triangle, I have three angles that are all the same. So that means this is an equilateral triangle. That means that all of the sides should be equal to each other. So I can write that 2x minus 14 is equal to 6. And I can solve to find that x is equal to 10. So I have a few for you to try here. I want you to copy the pictures onto a piece of paper. I want you to show all your work. Show me what you've done. I want you to find the value of x in each of these triangles, and then I want you to bring it to me. So again, find x in all of these triangles. Use the ones we did together in the lesson for examples, and then bring them to me. Make sure you draw the pictures.